We're at the end of the new release candidate process and Bevy 0.14 is officially out. We've got a ton to talk about, but I want to start by pointing out the official blog post, which lists the full extent of the changes, including links to the relevant pull requests, as well as the migration guide, which covers everything you could want to know about upgrading your applications. The Bevy project hosts a game jam every even release, so we should expect to hear about the dates for this release's jam soon. One of the results of the new release candidate process is that many crates in the ecosystem already have a 0.14 compatible code in releases or in PRs. This should mean that many will be ready when the jam happens in a few weeks. We're going to run through a whole bunch of stuff at a pretty high level, so keep in mind that basically everything we talk about has a corresponding example in the Bevy repo that dives deeper. And with that, let's kick off the new features with rendering. There are many rendering features in the 0.14 release, but one that has been in development the longest is Meshlets, which you may know by the names Virtual Geometry or Nanite. Managing the amount of geometry in a scene is an ever-present concern. Even GPUs have constraints after all, and freeing artists of those concerns is a worthy effort. Nanite-style approaches can support geometry on the scale of 500 million triangles, and Meshlets in Bevy is an experimental new feature that moves in this direction. In Bevy, the feature revolves around pre-processing meshes and a specialized render pipeline. A build time feature enables asset processing, while a runtime feature enables the spawning of meshlet meshes. This virtual geometry approach isn't perfect and still has its own limitations, but greatly expands what's possible. Future work includes functionality like automatic processing of GLTF via Bevy's asset pre-processing system, and more. Also keep in mind that in Bevy, when using the meshlet pipeline, you do not get access to the vertex shader, which is hard-coded, but the material trait allows the overriding of fragment shaders with these specialized names. There is an absolutely fantastic deep dive by the author of the feature that is a must-read for those interested in the implementation details. And even if you're not interested in the implementation details, I think it's worth reading at least the overview to get a good look into what this powers. Remember, Meshlets is experimental this release cycle, so have some fun with it. Up next, let's talk about SSR. Tiny Glade is a beautiful indie cozy tower building game that has been getting great reviews. It uses Bevy's ECS and has some very experienced rendering engineers building their own renderer. Building on their work, Bevy's own renderer has grown an implementation of screen space reflections, or SSR. Screen space reflections approximate real-time reflections by ray marching through the depth buffer and copying samples from the final rendered frame. To make use of these reflections, add Screen Space Reflections bundle to the relevant camera and configure the settings however you wish. Moving on from reflections, let's talk about volumetric fog and lighting. God rays, as they're known, or light shafts, are visibly stunning effects. Volumetric fog is a 3D fog effect that enables the creation of light rays shining through it. This work is built on top of a number of sources, and to add volumetric fog to a scene, you would add the volumetric fog settings component to your relevant camera, and then the volumetric light component to any directional lights that you want to be volumetric. It's important to note that the computational overhead scales directly with the number of directional lights the effect is applied to, so apply it where you need it rather than on everything. I mean, unless you've got a 4090 and then I guess do what you want. Other rendering effects in 0.14 try to mimic the way a camera really works. One of these is motion blur, which is a blur effect used to convey high speed. You can think of the effect as similar to what happens if a camera lens is open for a long period of time when taking a photo. Bevy's implementation of motion blur uses motion vectors, which means it works with Bevy's built-in PBR materials, skinned meshes, or anything else that writes motion vectors and depth. You can use motion blur by adding the motion blur bundle to the relevant camera. And a common process when using a real camera is to color grade the resulting output. Bevy has been growing more tone mapping color tools over time, and supporting artists is an important goal. To this end, Bevy continues to grow to support white point adjustment, hue rotation, and other color correction. The new color grading example shows off all of the color grading settings. And if you've ever used a camera before, you might know something about exposure. Bevy already supports setting camera exposure manually, and in 0.14, Bevy introduces automatic exposure. This is not a replacement for handcrafted exposure, but rather a tool to create dramatic effects when brightness changes rapidly. To make use of auto exposure, you must add the auto exposure settings component to your camera, and additionally, add the auto exposure plugin to your application. A classic camera effect is depth of field, which is also coming to Bevy in 0.14. This mimics the behavior of a real camera, blurring out of-focus elements and creating bokeh. By default, Bevy simulates standard cinematic cameras with an f-stop of 1 and a film size corresponding to the classic Super 35 film format. To make use of depth of field, add the depth of field settings component to your camera. You may be sensing a theme here, as many rendering features are as easy to use as adding a component to your camera. And here we've got a couple of quick fire features. First up, Anisotropy, which has been added to Bevy's standard material in the Anisotropy strength and Anisotropy rotation fields. A texture can also be provided. This creates an effect similar to light hitting brushed metal or hair. Percentage closer filtering, or PCF for point lights, is an anti-aliasing technique that results in softer, more natural-looking shadows without any changes to user code. Subpixel Morphological Antialiasing, or SMAA, is another anti-aliasing technique that adds to Bevy's list of techniques. MSAA, FXAA, TAA, and now SMAA, all of which are meant to, reduce jaggies. Visibility ranges, or hierarchical level of detail, is a foundational tool supporting the idea that models that are far away are harder to see, and thus don't actually need full resolution. And finally, for the rendering features, GPU Frustum Culling. Frustum Culling is an optimization technique that automatically hides objects that are outside of a camera's view, which, in rendering terms, is its frustum. In Bevy 0.14, users can choose to have this work performed on the GPU instead of the CPU. This choice will depend on the performance characteristics of your own project, so feel free to add and remove the Frustum Culling components as you see fit. Next up, we've got a couple of features coming to Bevy UI. First off, rounded corners. Rounded corners are extremely popular in UI work, and Bevy now supports them. There's a new example showing off the new functionality, which is implementable using the border radius struct. And I don't know about you, but I remember using border 1 pixel solid red in my CSS to debug layout issues in the browser. Truly a classic. Well, now you can have that experience automatically in Bevy with UI node outlines. This is technically a gizmo, and you'll have to add the debug UI plugin to your application to make use of it. Some big changes for animation include animation blending. Animation is a bigger topic than it seems at first. And yes, 2D sprite animations can be powered by cycling texture atlas indices, but 3D animations are often combined programmatically. Consider a third-person 3D shooter, for example, which will combine walking and running animations keyed to the speed of movement with aiming and firing animations based on where the player is looking. To this end, in 0.14, the Animation Composition RFC was implemented. What this means for you is that a root animation graph component can have clips added to it, which can then be weighted, blended together, and played back. A major new change to the way color works in Bevy comes in 0.14. This is a totally revamped color API. Concretely, this means things like color palettes, for example Tailwind or CSS defaults, are now available, and perceptually uniform color spaces like Oclab are supported. Most of the time you'll find yourself using the color struct, while linear sRGB-A has been created to be concrete about what format the GPU accepts colors in. Bevy Color, the new color crate, is also usable as a standalone dependency, so feel free to make use of it in your own non-Bevy related projects. Color is one of those things that is more complicated than it seems on the surface, so check out the wonderful diagrams in the documentation to get a handle on how to make use of these different color spaces and the new functions. But let's talk about geometry. Shapes have seen a major explosion in 0.14 with a whole host of new traits and functionality available on the broad set of new shapes. This includes constructing new shapes, measuring area and volume, sampling randomized points and the interior or the boundary of the shapes, constructing and extruding meshes, getting bounding boxes, and even wireframes. All of this works for the new built-in shapes, as well as any custom shapes you may want to make yourself. And just like shapes, Gizmos had a bunch of new entries in 0.14 as well. Some of the more interesting gizmos, in my opinion, include the automatic gizmos for directional lights and axes for transforms. There are also other new additions like rounded boxes and grids in 2D and 3D, as well as control over the line and joint styles making these gizmos up. Want to show a box as a red dotted line gizmo with beveled joints? All yours in 0.14. Which brings us to ECS changes. Specifically, we're going to talk about observers and hooks. Bevy has accumulated a number of ways to react to changing data, and in 0.14 it gains 2 more, observers and hooks. Observers and hooks are major new features in 0.14 and are inspired by Flex. Component lifecycle hooks react to a specific set of events immediately. This makes them basically comparable to constructors or destructors, so you're going to want to make use of them for when components are added or removed. Let's say, for example, a health component is added to an entity, and you also want to spawn a health bar display, but you don't want to have to manually remember to set up the health bar display every time. A component hook keyed on the onAdd event in the implementation of the component can do that for you, guaranteeing that a health bar will always exist for an entity with a health component. You could imagine significantly more complicated use cases, such as adding entities to a spatial index when a component is added to them, and removing them from that index when the component is removed. Observers, on the other hand, function a lot like hooks, but are meant for application-level behavior. Observers can listen globally for built-in or user-created events using system-like functions. The main requirement is that the observer has the event that triggers it in a trigger param as the first argument in the system. Observers also run immediately, so can be useful for things that need to happen immediately, like dealing or taking damage. The trigger parameter also allows access to the event data and the entity responding to the event if there is one. You can combine observers with, say, commands that trigger events to immediately process data that can't be out of sync. Observers and hooks are very new, so expect more to be built on them moving forward, including some things we'll talk a little bit about later, including interesting behavior around relationships and hierarchies. But onto something a little bit lighter, queries can now be joined. This is an inner join if you're familiar with database terminology, and more joins could be added in the future, maybe by you, so go check out this issue. And of course, state machines rule everything around me. Get it? State machines rules? In 0.14, state machine abstractions gained two major new features, substates and computed states. Computed states can be computed from one or many source states. These are the states that you're already used to using if you're using Bevy. This allows using these other states to define a new derived state that can then be used separately when deciding what systems to run. Computed states cannot be mutated using next state. They can only be computed from their parents' states values. Substates, on the other hand, are somewhat similar, but provide the ability to control them via next state, just like you're likely already used to. Substates have a source state, which means that they only exist when that source state is in the right value. This can be upped in complexity to depend on multiple source states with a custom implementation, and all of your previous states functionality should work as is. All of this new state functionality should work great for things like pause menus. Speaking of menus, the functionality we just talked about with computed and substates is extended by the new state-scoped entities functionality. Are you tired of writing systems to remove menu items when moving into the game playing state? Me too, but not anymore. State-scoped entities allow you to tag your entities with the state-scoped component, which will cause all of them to be recursively removed when exiting that specified state. No more custom menu cleanup systems. And finally, in the states saga, you can now opt into identity state transitions. This allows implementing refresh-like behavior by causing onEnter and onExit to fire when a state transitions to itself. This functionality is only available if you enable it though, so if it's not something you want, don't worry about it. And looking a little bit to the future, Bevy's adoption of working groups has been going, in my opinion, great. If you're looking to keep track of or join efforts, check out the working groups channel in the official Bevy Discord. Some of the active working groups include Relations, which have produced an RFC for linking entities together, the Audio Working Group, which is working towards the integration of Kira and formulating a better audio playing interface, the Contributing Book, which is making it easier to discover and maintain onboarding for new contributors, the Curve Crew are designing a trait to unify and power curves, which are ubiquitous in gaming, and the Lorem Ipsum Group, which is looking into better tech support. Additional work is also happening already. A new render graph is being worked on to power Bevy's rendering architecture, the Bevy Remote Protocol for powering editors, debuggers, and other tools. A new dev tool abstraction is being worked on, yielding a unified way to enable, disable, customize, and group developer tooling, and, of course, better scenes, which you can find out more about in the design doc. That's it for Bevy 0.14 today. We'll be covering new features like observers and hooks in future videos, so if I missed your favorite new feature, let me know in the comments below, and have a great rest of your day.